Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. Okay, so in this video we'll talk about geometric progression. Geometric progression is a sequence of numbers such that the ratio between two successive numbers is same. The same ratio is called as the common ratio in a geometric progression. An example is shown over here. Suppose the sequence is 2, 6, 18, 54 and so on. So now the first term of this geometric progression is 2. The next term 6, that is 2 into 3. Then the next term 18, it is 6 into 3. The next term is 54, that is 18 into 3 and so on. So what we are doing is we are multiplying 3 to the previous term. So the ratio that we are getting is 3. What it means is 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. Okay, so that is why the ratio is common everywhere. So the common ratio of this GP is 3. Now the first term is denoted by A in a GP and the common ratio is denoted by R. So for the above GP, what we can say that A is 2 and R is 3. Okay, so we'll do some more examples. So here a geometric progression is shown with the first term as 2 and the common ratio as 2. Okay, so 2, 4, 8, 16, 32, 64. So what we are doing is we are multiplying the previous term by 2 to get to the next term. Okay, so that is why A is 2 and R is also 2 over here. Now in this GP, the first term is 2 and the common ratio is minus 1. So the first term is 2. If the ratio is minus 1, we'll have to multiply minus 1 with 2 to get the next term, which is minus 2. Okay, so minus 2 is the second term. Then minus 2 into minus 1, that is positive 2. That is the third term. Okay guys, so that is how we get alternate plus and minuses, positives and negative numbers. So in this kind of a GP, A is 2 and R is minus 1. Now over here, we see again a GP with A is equal to 2 and R is equal to 5. So the first term is 2, the second term is 10. 10 is 2 into 5. Then the next term is 50. 50 is 10 into 5. Then 250, which is 50 into 5. And then 1250, which is 250 into 5 and so on. Okay. Now in this example, we see A as 2 and R as half, which is 1 by 2. Okay. So the first term of this GP is 2. The next term is 1. Okay, because 2 into half is 1. Okay, then the next term after that is half, because 1 into half is half. The next term after that is 1 by 4, because half into half is 1 by 4. Okay guys, so what we are doing is basically we are multiplying half to the previous term to get to the next term. Okay, so that is why A is equal to 2 and R is equal to half. Okay, so now to find the nth term of a GP, we use the formula AN is equal to A into R raised to power n minus 1, where A is the first term of the GP and R is the common ratio of the GP. Now an example is shown over here. So suppose that there is a GP 2, 6, 18, 54, 162, 486. Here we can see that A is equal to 2 and R is equal to 3. Okay, and we also know that the fourth term of this GP is 54. Okay, now we'll use the above formula and find the fourth term. Okay, it should come to 54. So the above formula is AN is equal to A into R raised to power n minus 1. Okay, A is 2, R is 3 and n is 4 over here. So we get A4 is equal to 2 into 3 raised to power 4 minus 1. That is 2 into 3 raised to power 3, which is 2 into 27, which is equal to 54. Thus the fourth term of this GP is 54. Okay, and that is what we expected. Alright, so this formula is working then. Now we'll do a question here. It says the first term of a GP is 4, the common ratio is 3, and we have to find the fourth term of the GP. Okay, so what we know is that A is 4, R is 3 and n is 4. And the formula for nth term is AN is equal to A into R raised to power n minus 1. Now putting the values of A, R and n in the formula, we get A4 is equal to 108. So that means the fourth term of the GP is 108. Now we'll do the formula for the sum of first n terms of GP. So if the common ratio is more than 1, then the formula for the sum of first n terms of GP is A into r raised to power n minus 1 upon r minus 1. Okay, but when r is less than 1, then the formula becomes A into 1 minus r raised to power n upon 1 minus r. Okay guys, so this is the sum of first n terms of GP. So there is a case wherein we can find the sum of infinite terms of a GP. It is the case when the common ratio is actually between 1 and 0, means it is less than 1 and more than 0. Okay, so the sum of infinite terms of GP is given by the formula A upon 1 minus r. Okay, we'll do a question over here now. It says the first term of a GP is 5 and the common ratio is 2. We have to find the sum of the first 8 terms of GP. So we know A is 5, R is 2 and N is 8. So over here R is more than 1. So sum of first n terms of GP is given by A into r raised to power n minus 1 upon r minus 1. Now we put the values of A, R and N in the formula and we get sum is equal to 5 into 2 raised to power 8 minus 1 upon 2 minus 1. Okay, which is 1275. Thus the sum of first 8 terms of the GP is 1275. Okay, now so over here we have to find the value of 3 plus 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 till infinity. Okay, as we can see that this is a geometric progression with A is equal to 3 and R is equal to 1 by 3. Okay, and R lies between 0 and 1. Now we need to find out the sum of the series till infinity. So we'll use the formula for sum, which is given by A upon 1 minus R. So sum is equal to A upon 1 minus R. We'll plug in the values of A and R. Okay, so A is 3 and R is 1 by 3. So by plugging in the values we get sum is equal to 9 by 2. Okay, which is 4.5. Okay, thus 3 plus 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 till infinity. If we add this geometric progression, we get our answer as 9 upon 2. Okay guys, so this is all about geometric progression. Thanks a lot for watching this video.